So we learned about the terms of 2 force members, 3 force members, etc. So the number has to do with the number of locations on the member where there are forces or reactions, right? So looking close at this one, there's a pin here, a pin here, a pin here, and a pin here. So member A, B, E is a 3 force member because there are reactions at those supports. C, E, F is also a 3 force member because there are reactions here, and a force here. And member B, C, D is also a 3 force member because there are 2 pins, and then there's a roller which has a reaction at it. And then if you look at the second problem we looked at, we noticed that there's a pin here, and a tension here. So this is a 3 force member. This one, A, B, C, F, has a pin, a pin, a pin, and a pin. So that's a 4 force member. And then for CD, because there are only reactions at the ends, it's called a what, Amani? CD is called a?
Can you repeat the question, please?
Yeah, since C and D, they have reactions at C and a reaction at D. Is that a 2, 3, or 4 force member?
2 force member.
2 force member, right. So is CD a multi-force member, Amani? Is CD
No.
a multi-force member?
It's a 2 force member.
It's only a 2 force member. But how about Angel? Angel, what about BE? Is that a multi-force member? He's coming in and out. Bon?
It looks like there's 3 forces on it, so I'm going to say it's a 3 force multi-force.
Right, it's a 3 force member, and it's also called a multi-force member. A multi-force member has to have 3 or more. Okay? And then what we did on Tuesday also is we just got more practice of drawing free body diagrams. We drew all the free body diagrams of all the members on this problem, and we did the free body diagrams of all the members on this problem. Okay? So now we're going to do a statics problem now. So the first step, if we want to write steps for frames, maybe we'll write down some steps and then I could update them in the overview, is first to see what number members, what number force each member is. Okay, and the reason we want to do that is take a look at, I'm going to remind you about a problem we did a way back. Everybody's with me, right? Do I see some nods or thumbs up? Okay, remember this problem? This was our first statics of particles problem. We found out that the tension was an unknown. The weight was given of 1,000 pounds, and the strut was unknown. And what we decided, because there were 2 unknowns, we wanted one free body diagram, and we chose C, and we said tensions away, weights down. We have our X and Y. And then we put the strut, and I think we put the strut in this direction. Let's put some angles in here. 25 degrees. If that's 60 here, that's 60 degrees here. We put the strut away just because we wanted to draw it away. Do you remember the value? Taking a look at this free body diagram, did we get a positive or a negative for the S?
A negative.
Colin? I don't see Colin. Daniel C. Nope. Daniel H. Nope. Danny.
Yeah.
Do you remember? Look at this free body diagram. We have tension drawn up to the left. We have weight drawn down.
Mhm.
Is this S drawn in the right direction to balance this off?
Yes.
Take a look again. You don't have to go back. Don't go back in history. You know it now. So take a look. We have T going up to the left. We have the weight going down. Does this look correct that S should go down to the left? Static equilibrium.
What is that supposed to be?
It's a strut. It's just another force.
Oh, okay.
Which way does S have to go? Down to the left or up to the right to balance this off?
Up to the right.
How come?
Or to balance out the weight.
Yeah, so it really needs to be drawn like this because we have a weight going down, we have a tension going down, right? So, I mean, tension going up,
Yeah.
that's okay. But the main reason is to balance off this T. The T is going to the left. I need to have something going to the right to balance this.
Oh, yeah. Yeah.
Okay, that's very important.
Mhm.
Okay, so I was just kind of doing a little review, but my point really was notice what this member is. Dave, what is this member now that you know?
Now we can call it a two-force member.
Two-force member. And the rule is that two-force members, because this is a pin here, isn't it? You guys? This is a pin. Normally I would have a BX and a BY. But I didn't. We didn't have that. The reason why is because a two-force member has the reaction axially. I don't know if you know what the word axially is. It means along the axis of the member. And you could put a BX and BY here and put an equal and opposite here, and you're going to find out that that's what the case is. So whenever you have a two-force member, if I have a two-force member, take a look at this. Let's call this AB. I have an AX, AY, and I have a BX, BY, right? So if this was a member and this was a pin at the end, we ordinarily, with the knowledge we have now, we would draw an AX and AY here, and we would draw a BX and BY here. But now I'm telling you that whenever you have a two-force member, the force actually goes through the member. So this could all be replaced with a force like this. You could draw it like that, or you could draw it like that, either way. And of course, when you draw it, if you get a negative, it's going the other way. So let's call this AB and AB. So let me repeat that. David, when I have this two-force member, when I have this member AB, and it has a pin on X and a pin on Y, how many unknowns do I have here, David?
Just one.
Well, the way it's drawn right now.
Oh, four.
4. There's AX, AY, BX, BY. There are 4 unknowns. Oh my God, that's a lot. But now that we know, and boy, Jason's missing the trick. Oh no, here he is. He's here. Because, and it's not really a trick, because I could solve for these 4 unknowns and you would find that the direction of them is along the axis. So now, David, I reduce the 4 unknowns to how many unknowns?
2 unknowns.
Actually, these are the same.
Oh, there's just a one. Just a one.
It's only 1 unknown. So I reduced it from 4 unknowns to 1 unknown. Awesome. It's kind of like the thing with a couple. When you recognize a couple, all of a sudden the problem gets simplified. It's the same thing here. When you have a two-force member, the pin reactions at the end go along the direction of that, along that axis. which means in trusses are all 2-force members. All the loads go along those members. So let's take a look then at this problem. And I know you liked the other copy of it, so let me pull out the other copy and then we could zoom in. So Edgar, where is our 2-force member here?
The DC beam.
Say it louder.
The CV beam.
CD beam, right? CD beam, this L bracket, right? And I already mentioned that we don't need to have this here. We could just have a member going straight through. So when we drew the free body diagram for CD, let's go back to our free body diagram for CD. Everybody could see it? Notice we had a CX, a CY, a DY, and a DX. But now we know that because it's a 2-force member, we know where the directions of those reactions are. So what should I draw instead, Edgar? We're going to get rid of these CX, CY, DX, and DY.
So that means, can we now just draw a line across DC and
Yep,
make a single force? Let's call it DC.
right. And would you like to draw the forces going towards each other or away from each other? You could do whatever you, well, actually,
It seems like
Let's-
towards.
yeah, let's mimic what we did here. So that means, here's my line. This is CD. And this is DC, but really they're the same, right? So you could just call them CD. I think we should just call them CD. So it doesn't look like we're introducing more unknowns. Edgar, you see that now?
Right.
So we
yeah.
took 4 unknowns and we made it 1 unknown.
Cool.
Elizabeth, no. Eric? No. Gerardo? Yeah, Gerardo. There are other free body diagrams that we drew CX and CY and DX and DY in. So what do we need to do there? So look at member A, B, C, D. What do we need to do? Okay. Hyoji, no. Isaac.
Yeah.
So I just reduced CX and CY and DX and DY. What about in this free body diagram? I need to reduce something. I just got rid of CX and CY, right? And instead put CD.
Yeah.
I'm noticing that here there's a CX and CY.
I mean,
I'm going to get rid of them. And what am I going to put?
oh, you're gonna put in DC.
Right.
It would be a compression. Wouldn't it?
It's well, let's not talk about tension and compression, okay?
Okay.
I prefer not to talk about that because we're going to get to that in trusses, okay? So let's not call it, just call it, is it up to the left, up to the right, down to the right, down to the left?
Up to the right.
So I have to draw it up to the right because it's equal and opposite this point C.
And
Right?
and we could probably do that with if we're gonna reduce, what is the other one? EB, AB.
Right, so here we have a DX and DY, so we got to reduce that too. So where else does it get reduced? On the main structure.
At D.
Right, so DY and DX are gone. And I'm drawing CD. You guys are all smiling, so you must be chatting or something.
that we're making bad puns in the chat.
There's a great
Oh.
joke in the in the
Oh,
text.
okay. Okay. Okay.
CB beam.
Oh, CBD. Got it. Okay, so Isaac, one more question.
Yeah.
How come here at D,
Mhm.
I'm drawing it up to the right, and here at D, I'm drawing it up to the right as well? Why aren't I drawing them equal and opposite?
I mean, they're at the same point. They're the
Same
s-
point, same
Yeah.
member, same
Yeah.
member.
Yeah. Why wouldn't you?
Well, there are times that when two things get connected, right? And I draw them equal and opposite because these two members connected at C and I draw them equal and opposite. But this point D is the same as this.
Yeah.
If I were to draw this little guy over here, this is a fixed support. There would be a force
yeah.
in the X, a force in the Y. I'd have a moment. And here is where I would draw CD going equal and opposite.
Yeah.
Yeah, for the C end, you had to flip it for that other diagram, right? Because that
Right.
was
Because
internal.
these
Yeah.
two connected.
Okay.
Because at joint C, when I drew it, the force on this member at C, it went in one direction. But when I drew the joint at the other member, the reaction had to be equal and opposite.
Okay.
Because when you put them together,
Yeah, that's fine. Yeah, I guess I don't know. I guess it seems self-evident.
okay. So,
Joanne, can I ask a question?
yes, please do.
So for the two force members, you said that the force is always along their axis, right? Does that mean that
For two force members, they're always along their axis.
And so does that mean that that's the shortest distance between them? Because like
Yes,
okay.
yes. Shortest distance. Even if this was a curve, which maybe they would have put in because they're trying to be aesthetic, it would still go right through the 2 points. Okay, so when I use the word axially loaded before, that's really assuming that it's a straight line. It connects the force, so maybe it would be better if I didn't say axially loaded, but rather said the reaction connects. No, connects doesn't sound good either. Connects the connections, that doesn't sound good. The reaction at the support is in the direction of the other support, maybe?
Yeah, that makes sense.
So certainly if it's a member where it is only a line, it is axially loaded, and you're going to see that a lot in trusses. But otherwise, we should say if there's a two force member, the reaction at the support is in the direction of the other support. I think that's a good thing, a good way to say it.
Mhm.
Okay, what other questions? So
Is that the only member you can do that to because it's the only two force member?
correct. So member B, E is a 3-force member, member A, B, C, F is a 4-force member. You could only do it for 2-force members.
So how does it, I'm not picturing how it simplifies the equilibrium equations at this time.
The reason why is I just reduced the number of unknowns from 4 to 1. That's huge.
But like
Because
how
if
you
I
act-
kept the 4 unknowns, I need 4 equations. But right, by reducing it to 1 unknown, I only need 1 equation.
Okay, so it's one in it. And
You'll end up breaking it into components though, right?
yeah,
Yeah,
need-
you'll break it
right,
into components, but you do know the
right.
directions.
Yes,
Okay.
Right.
direction, exactly. Directions are
You know
known,
the
but you only have
directions.
one vector CD, and you don't care which like you have 2 CDs drawn, which are not the same vector, but the same,
Correct, they're the
Magnitude.
same magnitude.
same magnitude along the same line.
Right. Okay, another question? So let's just, for a moment,
But I think that as we start actually using it, it'll become clear how it simplifies things.
yeah, I mean, just think, you don't need 3 more equations, like, it's gonna save you a ton of time. I'm just gonna pull up some textbook questions. Like, look at this problem right here. We have a bar, we have a collar sliding on it, and we have a member that has a roller here, and the pin is on the collar. Is there a 2-force member here? Let me see, where am I? Jason, did I already use you, Jason?
No.
Okay, Jason, is there a 2-force member here?
Yeah. L.
Yeah. What?
The roller rod.
Right, this rod right here, because it only has a pin here and a roller. That
Unless
means,
it has weight, and then I don't know.
well, if it has weight, then it's, if, that's a really good point. If it has weight, then it's not a 2-force member. But
Interesting.
typically we ignore weight. Let's,
Howard Trust is 2-force
Oh, it
members and
has
they
a
all have
weight.
weight.
okay, so let's just ignore it doesn't have weight, all right, for now?
There it is.
It's a 2-force member, the force would be right through it.
Mhm.
Here's another one. We have 2 bars, 2 collars, pins, and here's a 2-force member. The load goes through it. Okay, I think you get it now. Okay, so now let's solve the statics problem. I'm going to start with the smaller one. Okay, so we're back at this problem, okay? And so what we did on Tuesday is we got practice drawing free body diagrams, and just earlier today, we learned about what the effective 2-force members are. Well, now we're going back to the statics problem, okay? Do we not have to ignore weight for any 2-force members? The problem will always tell you whether you ignore the weight or not. If they don't say anything about weight, you ignore it. Okay, so
If it's
we're on,
vertical.
not necessarily if the loading is so high. If you're building, think of these structures as toothpick bridges. When you build a toothpick bridge, you don't care about the weight of the toothpick,
You sure
but
don't.
the
yeah.
loads are gonna be larger than the minuscule weight. It's the
Right.
same thing with the truss.
Okay.
Okay, we're going on. We're on Jason Lee. Jason, you here? Actually, you know what? This is a good time for me to make my announcement. So I finally figured out how to get the videos correct. So when I put on my iPhone as a document camera, I have to make the iPhone the host and then record from my iPhone. So I went back to all the 3 videos from last week and on Tuesday, and they all have me, my face, and talking, and you don't see anything I'm writing. So sorry about that. Okay. At the end of class, remind me to announce that we're going to have a second interview coming up. Okay, so we're going back to our process for statics problem. So Jordan, you're here, right? Yeah, Jordan. So the first thing I do on a statics problem is what?
Find everything.
Right.
Find what you
Given.
have.
Given and find. The sketch info, and let's read the problem. Determine all the forces acting on the members. Nothing different given in there. Find. So Jordan, keep going. What do they want us to find? They want us to find all the forces acting on member ABE. So let's look at ABE. What forces are they? There are no 2-force members in this problem. So Jordan, what do I need to find?
AX and AY,
Yep, what else?
BX and BY, and EX and EY.
Okay. So now, normally we would draw a table, right? Jordan, how many unknowns are in this problem? Actually, we looked at it the other day because I circled them. 2,
Six.
4, 6, 8,
Wait.
9.
Hmm.
I'm looking at all the free body
Oh,
diagrams.
the whole problem. I thought you meant just
Yeah,
one.
and actually, I mean, we wouldn't have drawn the free body diagrams yet, right? So let's just look at the picture. There's 2, 4, 6, 8, 9. There are 9 unknowns in this problem.
Mhm.
If we had to solve for all the unknowns, how many equations would we need? Jordan,
9.
9 equations. But how many unknowns do we have to find?
6.
6. So I'm hoping that I only need 6 unknowns. But that's not necessarily the case. Okay. So I'm not going to draw the table. So for frames, no table for now. And let's decide at the end whether we want to draw tables or not. So at this point, we know we need 6 equations. So Jordan, how many free body diagrams am I going to need? It's 2D.
2.
2. How come?
We don't have enough. I mean, we have like a lot of points, but we don't have enough equations to find all 6 unknowns.
Correct. And for each 2-dimensional body, how many equations can I get from each 2D body?
4.
Try again.
3.
Right. For a 2D problem, I have some of the forces in the X, some of the forces in the Y, and some of the moments. I have a maximum of 3 equations. Since there are 6 unknowns and I need 6 equations, I'm going to need at least 2 bodies. If, when I draw a body, it results in introducing another of these unknowns, I'm going to need another body. So let me say that again. We need to find 6 unknowns. So we need 6 equations. So we definitely need 2 bodies. But if by using those bodies, I introduce another unknown, I'm going to need another free body diagram. But we're going to try to minimize the number of free body diagrams we have to draw, even though we drew them already for practice. Okay, so on frame problems, we always draw a free body diagram of the whole structure. And we always draw a free body diagram of the member, the body that they're asking us to find the questions of. And I'll write these steps out. So, you guys, on a frame problem, we always draw the total, we take the total structure away from its main supports, and its main supports are AD, and we always draw that free body diagram. And since the question says, determine all the forces acting on member ABE, we always draw a free body diagram of the member in question. Okay. So what do we need to find? We need to find the reactions at A, B, and E. So here, I need to find AX, AY, BY, BX, EX, EY. I'm going to have to find everything on this free body diagram. But on this free body diagram, I only have to find AX and AY. N, they're not asking us for N. And yeah, we know the 150. So now, you guys, I'm going to give you a few minutes. Look at these 2 free body diagrams and think of what equations you want to do first that'll give you some solutions for the unknowns. Don't blurt it out. I'm going to give you a few minutes to look at both these two highlighted free body diagrams and figure out which equations you want to do first to find some of the unknowns. You don't need to do the calculation. You know how to do math. Just figure out what you're going to do, which equations you're going to do first. So Laura, you're up. Which free body diagram do you want to use first, and what equations do you want to use?
The one with the whole thing.
The whole
No.
structures. So you want to do the free body diagram total, and what equations do you want to use?
The sum of the forces in the X.
Sum of the forces in the X equals 0, and what would you find?
That
Which unknown would you find?
The AX.
Right, great. And then is there another equation you want to do on that figure?
No. Well, we could do another one, but we would have two unknowns.
Okay, so if we did sum of the forces in the Y, we would have two unknowns. But what other equation can we do that'll give us AY?
We could do the moment around D.
That's correct. And you know what? On these problems, the moment equations are usually the most helpful. So you do sum of the moments. Actually, what I would like to concentrate on, we have 50 minutes left. I'd like to concentrate on the process and not do the number crunching. And then I'll post the solutions. Is that okay?
Yeah.
Everyone? Okay. So first we did sum of the forces in X, and we would find out what AX is. Then we would do sum of the moments about D equals 0, and we would find out what AY is. Okay? All right. Let's see. If we find out, so now so far we have two of the unknowns they're asking us for. Laura. Is Jack here? Yeah, Jack, I went over you by accident. Jack? Is there another free body diagram, the highlighted one? Is there an equation you'd like to do to solve something? Okay, we're going to skip them. Liam? No. Luis? No. Mackenzie? Marcine?
Yeah.
Look at this free body diagram. For free body diagram ABE, are there any equations you'd like to do to solve something?
We could do, since we know our AY and AX, we could do moment about B to find our EY and EX.
Great. So let's see. We do sum of the moments about, let's see, if we did sum of the moments about B, AX would be in that equation, right?
Oh, yeah.
But EX and EY would also be in that equation. Huh. So we would have two unknowns in that equation, right? Does everybody see that? If we did sum of the moments about B, I would get an equation with two unknowns. Let's try a different place. Marcine, how about if we did sum of the moments about E? It would be the same thing, right? BX and BY would both create a moment about E.
Yeah.
So then we would get two equations with two unknowns. which we might have to resort to, huh?
I
Could
have
you
a
pick another
question.
point, like maybe a moment around the corner?
Okay, let's see. If we did moment around the corner, EX would go through there and BY would go through there. But BX and EY would create a moment.
Oh
So
yeah,
then we
yeah.
would
Sorry, you're right.
we would still have a moment.
Joanne,
It looks to me that the free body diagram for ABE, and maybe not, these two free body diagrams alone are not going to be able to give us those unknowns. I saw somebody light up.
I
Maria.
was- yeah, I was gonna ask, could you do a moment about a line? Like about the line A?
Ah, okay. So if we did a moment about this line, everything would cancel out. Everything would cancel out,
Even EX?
right?
is
So
along
let's
that
try,
line?
right? Because EY is parallel to the line, EX intersects the line, and these guys all intersect. Let's try, how about this line? Awesome. Look at you, Maria.
Wait,
Woohoo!
No, but hold on, but that one, everything the same happens. BY intersects, BX is parallel.
Oh, yeah, and
Can't we
BX and
only do-
BY are parallel.
So that's
Okay, nice.
not
Nice try.
helpful.
Yeah,
That
isn't
with
moment
everything canceling.
only useful in 3D?
No, there
No.
might be complicated 2Ds that it works. I don't know.
Yeah, there could be components. Like it
Yeah.
just they all happen to be ortho.
Yeah. Okay, so now take a look. So let's just, since we're gonna wind up having to use this free body diagram anyway, because it's the one that has all the unknowns we want. So let's do the sum of the moments. Laura, were you the one saying no, it was Marcine. Let's do some of the moments like you said. We'll do some of the moments about B. And that's going to give us an equation with AX in it, EX, and EY. And we already know what AX is. And then we could do some of the moments about E. And that would give us an equation with AX in it, which we know. BX and BY. So we have a relationship between these at least established. Are you guys cool with me not writing out the equations? I'd rather talk about the process. Okay. So if we did some of the moments about B, AX would create a moment and so would EX and EY. If we did some of the moments about E, BX and BY and AX and AY
Yeah,
would
I
create
was
a
gonna
moment.
say I think it's all four. Great.
Yeah.
We can't make
All
it
right.
a couple.
So that means you guys, we need to use another free body diagram. So who are we on now, Marcine? Maria, look at one of the other two free body diagrams.
Maybe use the free body diagram CEF and do a moment about C.
Great. Yeah. So we could use a free body diagram CEF and do some of the moments about E, and that's going to have CX in it, and it's going to have 150 in it. We're going to get CX.
Wait, hold on, what?
Sorry. So if you said to do the moments about E, right?
No, I wanted to do the moment about C.
Oh, okay. Well, we could do that one too. The moment about C is going to give us EX and the 150, and we're going to be able to find EX.
And isn't that one of the ones we need?
Yes.
And then we can plug it back into the.
Right,
moment.
because we don't need CX at all.
No.
Good point. So we do the free body diagram of CEF. We do some of the moments about C, and we get EX. Okay. So now, Matthew? Oh, Mackenzie, I skipped you. Mackenzie. Now, so we have AX and AY. We have AX and AY. We now have EX. Can you see an equation from this ABE that we could use, since now we have AX and AY and EX? Can you see an equation that we could find another unknown?
Could you find the BX?
Yes, by what equation? One of the easy ones.
Would it be the moment around?
But just
Okay.
take a look at this. I put check marks on all the ones I have. I have EX, I have AX, we need BX.
Can I pass?
Sure. Yeah,
you.
Mackenzie, don't pass. It's all the X's. So let's not think different.
Oh, so you just do the sum of the X's?
Right, some of the forces
Okay.
in the X. It has AX, which we know. It has EX, which we know, and we could solve for BX. And now we get BX. Cool?
Yep.
All right. Matthew, no, Myra, can you see another equation? Take a look at ABE. Now we have AX, AY, BX, and EX. Can you think of an equation that we could solve BX or EY?
We can't see your screen anymore, but
Oh, all right, hang on. That's a problem when somebody calls. Okay. Thanks, Myra. So we're looking at this free body diagram. We have AX, we have AY, we have BX, and we have EX. What equation can I do? Actually, I've already done some of
could
them.
do the sum of the moments at E and then have BY, find BY that way.
That's right. Some of the moments about E, I have AX, I have BX, I have AY. I could now solve for BY. And then, Myra, now that we have BY, can I solve for EY?
Yeah, using the first equation there, the sum of the moments of B.
Yes, I could do
Plug it
that,
back
or we
in.
could do an easier one. Just do sum of the forces in the
Okay.
Y.
Yeah.
That would be AY, BY, and EY. So let's recap. Everybody ready to recap this? I guess if I was Joe, I'd put a hat on, right?
Yeah, you would.
Okay, so we have this problem right here, and it says that we need to find all the information in this member right here. In this member right here, I need to find everything. Okay. The only thing given is really the sketch information. So I wrote given sketch information, and I wrote find. They wanted to know everything in this member, and we noticed that there are 3 pins, so they all have an X and a Y. So I have to find 6 unknowns. I need 6 equations. So I definitely need 2 bodies, but we also noticed that there are 9 unknowns in this problem. And when we use an equation, we might introduce another unknown and might need another free body diagram. Okay. I think we don't need to draw a table. How do you guys feel about that? No table? Because the tables we always had put all the forces on it, and I would have to put all 9 forces on it, and we're only talking about those forces. If you want, we could just draw a table for, we could draw a table, since we're kind of used to drawing tables, we could just draw a table for all the unknowns in the body that we're looking at. And then we don't know any of the magnitudes, but we know all the directions. So how about we do that? We draw a table, but we only draw it for the unknowns that they're asking us for. How does that
And-
sound to everybody?
Sure, but the reasoning behind frames no table
The
in
reason,
the first place?
I thought maybe not do it because normally our table has every single unknown in it. And we could have problems where there are 20 unknowns, but we're only looking for 6 of them. So up till now in our statics problems, we always use the table and put all the unknowns in it. Maybe what we can say is we make a table, but we only make a table of the unknowns that we need to find. And then I would also put that 150 in because we know it. I mean, there is an unknown at this roller. There's a normal here, but I'm not sticking it in the table. So what do you guys want to do? Do you still want to do a table or not? And if you want to do a table, then I would suggest the table only including the unknowns that they're looking for, not everything else. Could more of you turn your cameras on so I could see faces? What do you want to do?
So I found the table useful because it would show you if it was solvable or not. But I
Okay.
think that might be overkill, what you're describing. We're like, well, it's certainly solvable. We have 20, but
Well, how
I don't know.
then, how about we do a table, but we only do it for the unknowns that we're looking for? How does that sound?
Well, then
Are
that
people good with
defeats
that?
that defeats the purpose that I had for it because it would show you how many versus how many you've
Okay.
got. So I mean, I think you do it in your find. You do it. Well, we have 6 unknowns. We need 6 equations. We can certainly make 6.
Right.
Uh,
All right. I think I'm just going to leave it up to you. For frames, you can make a table or not. For the other statics problems, you have to make tables. Okay. All right. So then after that, after we did the given and find, we always draw a free body diagram of the whole structure. And the reason why is that so many of the forces are internal. They drop out and we could find some forces. We also do a free body diagram of the main body that they're asking us about because we're going to need to know all of those. And then you can do another free body diagram. But I mean, you have options here. Take a look at this one. Maria chose to do the sum of the moments about C because we don't need C. We're given 150 and we could find EX. If we did one here, if we did sum of the moments about C here, we could find B, but we don't know the normal unless we solve for the normal in the total structure. So this type of problem provides a lot of flexibility on what free body diagrams you want to do and which equations you want to use. So a lot of you will approach the problem differently. You'll do different free body diagrams. So could I go to the next problem? And now I'm pulling up the sheet. I'm pulling up the sheet without all. I have the members drawn, but I didn't draw all it's blank. And I'm doing it specific for us to just think about this. So this problem says, determine the horizontal and vertical components of the forces at each pin. Oh my God. So how many unknowns are in this? Okay, where am I? Laura, Liam, Luis. Luis, did you come? No. Racine, Maria, Matthew. Myra, you went. Miles? No. Peter? No. Tim, you're on.
Yeah, good deal.
So walk me through all the reactions at these supports. What's
Yeah.
going on at E?
We've got EX and EY.
Great. How about at A?
We have a normal at A.
Great. How about B?
At B, we have BX and BY.
How about at C?
At
Remember?
C, we have CD.
Right, at C, it's a two-force member, we have CD.
Yep.
How about at F?
At F, we have FX, FY.
Correct. At D?
At D, we have CD.
Okay, so we have 2, 4, 6,
Mm,
8,
minus
9.
1A.
Oh, okay. 2, 4, 6. Right. 2, 4, 6, 7, 8. And they gave us the weight. They gave us the weight. So we have 8 unknowns. We're going to need 8 equations. So now I'm going to go to the sheet where we drew all the free body diagrams. And the first one you want to do is the full one. So Tony,
Yep.
we know we have 8 unknowns. We're looking at the free body diagram total because we always start with that one. What equations can we do to find some of the unknowns?
We could do some of the forces in the X and Y, and then we could do some of the
Okay, wait, hang
moments.
on, hang on. So some of the forces in the X is going to be, give me EX and the X component of CD, NN, right? So that's going to be 3 unknowns in that equation. Some of the forces in the Y is going to give me a CDY and an EY, right? So the
Yeah.
force equations are going to give me one equation of 3 unknowns and one equation of 2 unknowns.
Mhm.
Is there a moment equation that we can do that reduces our equation to 1 unknown?
I didn't hear you mention the weight.
Oh, and the weight. Yeah, sorry. I'm just putting in the unknowns to see if I could figure out one of the unknowns. Even if we did like some of the moments about this line, DAE, it doesn't help.
What about some of the moments about the line at the top?
Okay, right here. So some of the moments here will cancel out EX and EY. It will cancel out this. CDX is parallel, 0. CDY goes through it.
Oh,
So I don't see any equations that'll give us 1 unknown here. But let's look at another equation. Let's look at another free body diagram. You could see how this could get complicated, right? Lots of equations. And they want us to find everything. So maybe we shouldn't even be strategic on trying to decrease the amount of work because I have to find every unknown anyway. I have a total of 8. I have a total of 8 unknowns. I need 8 equations. I might want to just do some of the forces in the X and some of the forces in the Y in 4 free body diagrams and then plug it into my calculator. Because I don't know if you would say this, but I tend to make less errors when I do the sum of the force equations. When I do some of the moment equations, sometimes I use the wrong distance. Sometimes I put a negative when it's a positive. So maybe in this particular problem, because they're asking us for all the unknowns, maybe just draw 4 free body diagrams and do some of the forces in the X and the Y for all 4 of them, and then plug it into a matrix. What do you think? Maybe we should just be strategic and try to save time and be efficient on problems, frame problems, when they're only asking us for forces on 1 member. What do you think?
Seems like a calculator is really good at doing systems of equation, you know, plugging into a
Yeah.
matrix is easy, and doing some of the forces in the X and Y is easy.
Okay, so in this problem, as soon as they say determine all the reactions at the supports, we would just do our given. A given is the weight of 80 pounds and the sketch info. Our find is, I'm just going to write all, and then I would do a table that shows all of my 8 forces. I have an N, I have a BX and a BY, I have a CD. I have an FX, FY, I have an EX, EY, and then just do 4 free body diagrams and 8 force equations. What do you guys think?
It's a big matrix.
Yeah, it's a big matrix. It's a 8 by 8. Dave's happy.
I'm curious what your, you know, as long as we're talking about it, strategic approach.
Yeah.
might look like.
Say it again.
I'm curious what your strategic approach versus methodical would look like.
Okay.
You would
let's
hope
see.
to get less than 8 if you can strategically pick equations. But
Yeah, let's
Well-
outline and see if it looks
well-
more efficient
there-
to us.
Yeah, there are 8 unknowns. You're going to need 8 equations. Okay. When I did the problem, what I did is I looked at these, and you guys look up here, rather than, don't do the number crunching. You know how to do that. Let's talk more. If I look at my pulley, I could find FX and FY, no problem. Right? Everybody see the pulley? On the pulley, I have an 80 tension here, 80 tension here. I could find FX and FY. So you could do this free body diagram first. Then you could go to this free body diagram, because now you have FX and FY, and you could do some of the moments about N at point A, and you could find what BY is. No, actually, you could just do, yeah. No, you can't. Let me see where else
well,
FX and
CD
FY.
would cancel out, right? You'd have a CD up and a CD down.
Well, if I did some of the
Oh.
moments about B, CDY would create a moment. Yes, that would be the only force. If I took this free body diagram and I know FX and FY, I could do some of the moments about B, because these cancel, this cancel, and CDX cancels, but I could calculate what CDY is. And if I have CDY, then I know what CD is. So then I would have this done. Then I have the CDs. This free body diagram is not going to help me at all. But now I have, where else is, oh, and I have FX and FY. Oh, then I could do some of the forces in the Y here, because I have FY. I now have CDY. I could calculate BY. So you could do it strategically, but the only time I would do it strategically is if I know I'm going to save time. I don't know if this is going to save time. It's probably best just to do 4 free body diagrams and 2, some of the forces in the X, some of the forces in the Y at each of the free body diagrams. I don't think being strategic is going to save time. But in this problem, when I only needed to find some of the forces, being strategic does work. Everybody good? Okay, so let's now go to the overview. I'm going to share my screen. Now, I have no idea if the screen is going to show up. It's probably not going to show up. So what do I need to do now? I'm gonna try something. I'm gonna stop the recording on my iPhone. And then I'm gonna try recording on my laptop and see if you can then see my laptop screen. No, I probably have to make myself the host. Well, maybe I'll do that. Let's see, how can I do that? Can I make myself the host?
Yes, if you click on participants and then you see your laptop,
Okay.
as a co-host, you can just make yourself host from the phone.
No, it says that.
No, from the phone. You have to do it from the phone.
Oh,
your
I have
phone
to
is
do it
the
from the
host.
phone. Oh,
Yeah.
sorry. Thank you. All right, so I'm gonna go into, tell me again where I'm going?
Participants.
Okay, participants on the phone, and now I'm gonna make me the host, make host. Do you want to change the host? Yes. Okay. Wow, this is gonna be great. Okay, so now I'm gonna share the screen. And I'm in the overview. Can everybody see my screen now?
Yeah.
Okay. So I'm gonna move us over a little bit and I'm gonna edit.
I can see your screen, but now the question
And you can
occurs
help
to
me
me,
write
is
this so
this
it's
what is
clear for you.
recording?
What?
It should be recording whatever the host is showing. So if she's the host, I think
I
this
see,
is
so that was
what
the problem
recording.
last time. Okay.
Well, I'm not sure about that, so I guess we have to decide now. Should I stop recording? Marcine, do you know for sure?
I'm like 90% sure.
Okay, let's just
Pretty
do
sure.
it. Let's just try it. It'll be an experiment.
Also, when you share your screen, that automatically what shows for all of us,
All right, let's
no
not
matter
talk
what
about
we
that
pick.
right now, okay? We'll just leave it the way it is as an experiment. So I wrote in the intro, you already know how to solve frame problems. You know how to draw free body diagrams. You know how to do some of the forces and some of the moments. They are just like solving other rigid body statics problems. Frames are structures that consist of at least one multi-member. Frames and trusses are similar, but trusses only have two force members. Okay, what will you learn by the end of this module? 1, that members are referred to as 2, 3, or 4, or I should say multi. Do I put multi in here? 2, 3, or 4. I think up here it says, let me write multi-member. 3 force member or more. Does that make sense? Okay. So that members are referred to as 2, 3, or 4, defined by how many points on the member that the external forces and reactions it supports are located. Does that make sense, everyone? Please talk so I could hear you. For example, a 2-force member AB has all its external forces and supports located at ends, point A and B of the member. 3-force member has all the external forces and the supports located at 3 points. That sounds good to everybody? Yes?
Yeah,
sounds good.
Okay. For 2-force members, the reactions at the pin connection at the ends is an axial load, a force along the axis of the member, or a force connecting the end points if the member is a shape other than a shape other
Line?
than a line? Okay. So for a 2-force member AB, the reactions at the pin support is 1 unknown AB along the axis of the member instead of 4 unknowns. And you apply the force AB at each end in opposite directions.
Yes.
Does that sound good?
Mm-hmm.
Yes.
Okay. So that's the new information that you learned. Let me just save this and then open it again just to make sure I don't screw anything up. Save. Okay, now I'm going to edit it. And now, let's do the process. So free body diagrams for analysis of frames. The first free body diagram is the free body diagram of the whole structure separated from its main supports. Second free body diagram is the free body diagram of the member in question whose unknowns are asked for. And then third free body diagram, select another if you need more equations. Is that okay? And now we write process for frame analysis. And there's two processes, right? One, when you have to determine all reactions at supports and forces. And in that case, what do? Let me put a bullet, hang on. Okay, determine the number of unknowns, and you could do it from the table. And then determine the number of free body diagrams. So let's put an example. So an example is 8 unknowns. No, let's make it weird. Let's do 9. So we're going to need, and it's a 2D, 9 unknowns we're only doing 2D frames for a 2D problem. So then what number of free body diagrams would you need to have for that?
3 bodies.
Right. So I want to do a different one. 10. How many bodies do I need?
4 bodies.
4 bodies. Okay, and then select. I mean, I would just say do the force equations, but it's your choice. Select 10 equations. Select equation, select end, and solve for unknowns. Most probably using matrices. And but JP's suggestion to minimize error, sorry, I'm not gonna do the math, find the math thing. Sum of forces in X and Y as equations. That's my suggestion, but you could do whatever you want. What do you think? Good? You guys?
I have a question on that. As far as checks go, are we gonna have to end up doing like a moments setup for checks, or?
You mean do another equation for a check?
Yeah. You know what I mean? Because otherwise
it probably would be a good idea. You know?
When you say good
really
idea,
long problem.
would that be required on, say, a homework?
No.
Or would
I'll
that
say
be
suggestion. Do a moment equation check. I'll put this, do moment equation checks. It's just a suggestion. I mean, on an exam, I would do it. But on homework, maybe not. Because you don't want to go back. I mean, the point is, I want you to be spending time on statics. I don't want you to be spending time on algebra. So if you get the wrong answer, I don't want you to go back. So I would not do the checks for this. I mean, it's one thing to do the checks of the components at the beginning, because that's really quick. It's easy to do, you know, catch that at the beginning. But at the end, I don't want you to go back and take 3-4 hours to find your error. I mean, that's
Yeah,
a waste
'cause
of time.
Yeah, no, I totally agree. It would take
It's a waste of time.
to do it, and your likeliness of error with just a lot of some of the forced equations is pretty low to begin with.
Okay.
Would you describe any of these checks as taking the output of the matrix output of any of the individual forces, putting it back into one of the equilibrium equations, and
That
seeing
sounds
if it-
awesome. That sounds
okay.
awesome, Jason.
Okay.
Yeah.
Mhm.
So suggestion, don't waste your time doing algebra, spend more of your time doing statics. So yeah, I think maybe better suggestion. I had a math teacher that hated plug. He made us say substitute. Plug the calculated values of unknowns into your equilibrium equations. Yeah, I think that's a better suggestion. Let's take this off, okay? You guys? Or let me leave it there. So let's put this in as a check. Okay? I'll just leave that like that. So do the regular check. That's a good idea. All right, so now, how are we doing on time? We're coming to the end, huh? Okay, so for problem asking for unknowns in only one member. Is this helpful, you guys, to have this? Steps?
Yes, for sure.
Okay.
Yeah, it really is.
Yeah.
Okay, what about this? Determine the number of unknowns from the table. Well, it's your choice whether you want to do the table or not. Determine the number of unknowns from the find. Oh, so we're supposed to do find. I didn't say to do find, given and find. Got to do given and find first. It's easier to do. It's better to do this with you because so then I make sure that you understand. You know, you're helping me with wording. You're gonna determine the number of unknowns from the find. We have 5 unknowns. We need.
Something happened, Joanne. I don't think we hear you well anymore.
Yeah, I can't hear Joanne.
Oh no.
Joanne got Thanos snapped.
Got snapped.
Sure, 3151.
Could anybody hear me?
Okay.
You're still real choppy. You might be having like an internet issue.
Oh, okay, cool.
Okay. All right.
Do you know how to do that?
Okay. Back in. Okay, that's okay.
Connect with your phone.
Well, I am, but I'm trying to, we're looking at my screen. Browser. Right, I'm looking for the one at home. Which one? No, I think it's,
No, I don't think it's either of those. I don't think it's any of those.
could you go figure it out from upstairs?
It's taking time coming back on.
All right. Children. Could you guys hear me? No.
Now you're
Yeah,
okay.
better now.
Yeah, I
Now we
hear you
can.
now.
Yeah, we can hear you.
Wait for
About that here in the class.
Yeah, it's okay.
Setting up my phone.
Oh, no. Okay, what do you,
Set up Zoom. Your connection, whatever you normally do.
just go to Zoom now?
Yeah, and
All right, but let me say,
yeah, it's safe.
I'm, okay, am I, yeah, looks like I'm back on. Can everybody hear me?
Yeah.
Yeah, that's
Yeah.
better.
Thumbs up?
Yep.
Okay, so, yeah, my son is helping my mom put in a new printer and, he unplugged the Wi-Fi by accident. Okay,
That'll
so
do it.
now, yeah, okay, let's see. So my screen is not being shared, so let me share it again. Okay, where's my share? Okay, all right, so we were editing the process. Okay, we were looking at examples where it's a problem where they're only asking us for the unknowns in one of the members. Well, the question now, am I the host or not?
Your looks like your phone is the host.
Okay, so I want to let me be the host, right?
Yes.
Make
Yes,
host.
just switch your computer to be the host.
Okay, can't believe I remembered that part. Okay, for probably asking, so still do given and find, determine the number of unknowns from the find. You could make a table if you want. Example is 5. Determine the number of free body diagrams. So if there are 5 unknowns, how many bodies do we need? You guys, somebody call it out.
5. If there's 5 unknowns, there's 5 equations.
Right, so how many bodies do I need?
2.
2.
2.
Those.
Okay. And then, but I need 5 equations, right? So I should say, hang on. 5 unknowns means 5 equations, which means 2 bodies. So the same thing, I should write that up here. 10 unknowns means 10 equations, 4 bodies. Okay, select. So now the next thing is typically on these, you're going to draw a free body diagram. Select equations. I would do this. First free body diagram is the one of the whole structure. Second free body diagram of the one of the question, and we may not need any more. Only draw a third free body diagram if you need more. So first free body diagram, would that be that? Solve for unknowns. Solve for use equations. Use equations to solve for unknowns requested. Does that make sense? So the first free body diagram is going to be the free body diagram of the old structure, separated from its main supports, and you're going to use the equations. You're going to choose equations to solve for some of the unknowns. The second free body diagram is the member in question, and then you're going to choose equations to solve for unknowns. And then only draw third equations if you need more equations. And then okay, that took a long time. Does that seem clear? So if you're looking for all the unknowns, just pick the number of free body diagrams you need, do sum of the forces in the X and Y, solve it into matrices. If you're looking for the unknowns only in one body, then only draw 2 free body diagrams to start, the whole structure and the member that's in question, and solve for unknowns. Whatever equations, choose whatever equations to find those unknowns, and then draw a third free body diagram if you need it. I'm going to save it. Okay, last thing I want to do is okay. So this is the module from on Tuesday that was just a couple of days ago and today, and it's all on frames. Here's the overview we just did. Here are the photos of the erector sets, just to kind of give you an idea of what a truss looks like versus a frame. And then these were the 2 frame in-class problems. And on my to-do list is to solve the problems and post them. So I'll post them right under here. And then here's the Zoom recording from Tuesday, although it doesn't have any, the only visual it has is me. It doesn't have the notes, but this one will be good, hopefully. Okay, then, homework, let me put this first. I'm not putting them in date order. But now you have one homework from these 2 days. Normally you have 2 homeworks, but you only have one. It's one frame homework that has about 4 problems. You probably want me to post the solutions that I already did. I don't remember if there are any 2 force members in these problems or not. I don't remember. Okay, now we are going to be doing another interview. Remember the first interview I did, I met with each one of you to do statics of particles problem. Well, we're going into a second interview point. And I'm not having exams in the class. So consider these interviews as like an exam. So I'm going to open this up because I tried to be specific this time. It says, Joanne will meet with you from 15 to 30 minutes for this interview to assess your competency in solving statics problems. So the problems might be statics of particles. It might be statics of rigid bodies. Notice that pulley in the frame was actually a statics of particles problem. No, it wasn't. It's a rigid body problem. But I'm not going to test you on frames. I'm just going to pull statics problems. But you should understand 2 force members now. You will be required to follow all the steps outlined in the October 22nd and 24th module. Please treat this interview as an exam. Review your class notes, your homeworks, your quizzes, do practice problems so that you're completely prepared for the interview. I highly suggest that you watch the homework 1920 solution video that I made for you. Okay, so last night I went through every problem in homework 19 and 20, which was the statics of rigid bodies homework. And I walked through my process, and I think it's going to help a lot of people. All right. So I would suggest you watch that. Your grade on the interview, on interview 2, hang on, let me edit. Your grade on interview 2 can replace your interview 1 grade, of course, if interview 2 grade is better than interview 1. I heard from some students that the interview, even though it's worth 15% of the course, they really didn't deem it as an important thing, but more like an office hour. So I want you to know now, from now on, interviews are like tests. So when you do this interview, let's say you got a 6 on interview 1. If you get a 9 on interview 2, I'm going to replace interview 1 6th grade with a 9, and you'll have 2 9s. Okay? You may want to
6 on 2.
If you get a 6 on 2, but you got a 9 on 1, your 9 stays.
Good deal.
But you guys are not going to get 6s because you're going to prepare and you're all going to get 9s and up. You may want to you may want to set up and bring to interview 2 a 3x5 cheat sheet of the steps for solving statics problems. And you know where those are, right? They're under in October 22nd, 24th module. Okay. Please complete the following survey to schedule in 25 minutes. So I'm asking you when you're available and put in all the free times, and then I'll do it as a puzzle and figure out when everybody's meeting. And then keep watching. I'm going to start the interviews on Monday, if I can. So keep looking in your inbox because I'm going to email you times. All right, let me save this. I think I might start it. I don't think it's fair for me on a Thursday to tell you you kind of have an exam on Monday. So I think I'm gonna start it on Wednesday. So I'll do it from Wednesday of next week. So the interviews. Let me just write that.
I mean, I'm fine with doing mine on Monday. I already filled out the sheet.
Well, let me find out from you guys. Is anybody else fine with doing this Monday or Tuesday?
I'm fine with it as well.
Anyone else?
I guess like anybody who doesn't want to do it Monday or Tuesday, just put not available on Monday, Tuesday.
Right.
Okay. What is Wednesday? What date is Wednesday?
That's
The
the
fourth.
third.
No, the
4th to the
third is
10th.
It's
Wednesday,
election day.
November 4th.
Right.
Why is election day on a Wednesday and not a Tuesday?
No, it's on Tuesday. The third is on Tuesday.
Oh, it's Thursday. Okay.
I mixed it up. Sorry.
Okay.
Election fraud.
Please.
Everybody mail in your vote. Everybody mail in your ballot. Should have already done it.
Isn't it
Drop
busy?
it off. Dropping it
Yeah,
off is better.
mail it
Drop
in.
it off. Mail it.
Okay.
Drop off.
Interviews are Wednesday to Tuesday and Monday, Tuesday, if you want. Okay. All right. So I'm going to save this now. So let's go back to the module. Okay. So all the frame stuff, again, I have to make sure that I post the solutions. And so then you have a frame homework, solutions are posted. Here's the information about the statics interview. It says on October 30th, that's tomorrow. Because tomorrow, I want you to tell me when you're available tomorrow so I can start making schedules, okay? And then you should watch this video. And then I basically am up to date on grading. I graded all the homeworks now and all the quizzes. So there's a resubmit on this one rigid body statics quiz. Okay. Other things that I want to tell you about is I decided my kids are going home tomorrow, but I decided to stay another week and a half because we postponed the amount of time my mom came to our house because we were waiting on COVID testing. So I want to stay here and I'm going to be doing interviews anyway. So I'm going to be busy. I'd rather just stay here, have more time with my mom. So that's just so that you know, I'll be doing the interviews from here. And then Tuesday, originally we were going to start trusses, but we're not going to do trusses. We're going to do frames. Sorry, we're going to do friction. And the reason why is because trusses and I basically changed the order of stuff and ran it by Rob and he said it's fine. The reason why I did that is because trusses, you're really breaking members apart and you are in shear and moment, bending moment diagrams too. So those two topics I'm going to put after it. Friction really is still the same. It's still statics problems, but now we have F is the frictional force is equal to mu n. So we just have an extra equation. So I think friction is a better follow-up. It's continuing statics type problems. Then we go into this. So I have to change these dates and I'll do that too. I'll change dates. So, all right, I'm going to stop sharing. Any last questions from anybody? Hopefully the video comes out good today. Remember setup for the interview: given, find, table, free body diagrams. Don't forget components, right? The only time you don't have to do components is when all the forces are in the X, Y, or Z, but you have to tell me in the interview. Say, okay, then I would have done components, but all the components are already, all the forces are already in the X, Y, or Z. And then the equilibrium equations, and let's be efficient with equilibrium equations. Okay. Okay, questions. I'm going to shut up now.
What do you mean by efficient with the equilibrium equations? Like,
you know how
the one, or at least
how if we do some of the moments about kind of like this quiz you just had, where I said, oh, find this unknown with one equation. If the sum of the forces in the X and the sum of the forces in the Y have 2 or 3 unknowns in it, don't do that equation first. First, do the sum of the moments about B that allow you to find an unknown. You know what? I think there's a problem in the video because I turned my audio off when I'm talking now, because otherwise there was an echo. And probably what I needed to do was turn on the audio here, and I probably had to turn the audio off here. Now, still getting an echo. Oh, whatever, we'll see.
There was no echo before. There is now.
What?
We didn't get an echo before. We do now.
Right, I know.
No, I know what you're saying, Joanne. It's gonna pin the one that it saw talking potentially, right? Is the issue. The one that it heard audio from. But
Well,
at least that whole section was on screen share and it's all on Canvas anyways, so no
Okay.
biggie.
Okay. All right, questions?
Will you be in office hours today? And you're muted. You're muted, Joanne. No, I can't hear you. Thumbs up, you'll be in office hours today? Okay, thanks.
I gotta go. Thanks, Joanne. Have a good day.
Okay,
Thank you, Joanne.
yeah, you're welcome.
Thank you, Joanne.
Thanks, John. I'll see you later.
Thank you.
All right, bye, Joanne. Take care.
Bye, Tony. Okay, see ya.